Alright, so as we go through this, I did tell you previously at the end of the last video that we've learned basically all of the tools that we will need, 80% of the tools that we'll need going forward. A lot of the stuff that we're going to discuss is just the reapplication of those tools. So in this case, we're looking at for loops. We're already familiar with for loops. The ones that we used before were for x and range, and the range told you how many times a loop was going to happen. But you can also run it as for some variable. I've written value, but this could be x in values. This is the variable that contains the list. All this for loop means is I'm going to look at every single element in this list, and I'm going to do something with it. In this case, all it's doing is printing it, but all this means is I'm looking at every single value in the list and I'm doing something with it. You can either append, you can delete within the for loop, you can have if statements within the for loop, you can have another for loop within the for loop. But what matters is this structure of a for loop, again, the normal structure, the previous structure that we used was for x in range 10. And all this did was gave us a number, said it was going to run through the for loop 10 times. Value in values, all it's doing is replacing range 10 with basically the length of the values. You could even run it as range length values. You could do that. It's the same effect, but it's a little bit more straightforward, a little easier if you just type for value in values or for x in values. So these effectively do similar things. It's just what is the limitation of how many times the for loop is going to run. And that's what this value here represents. How many times the for loop is going to run. So, like I said, you could just do range length of values. It's the exact same thing. It's literally the same thing. It's just a different way to write it. So like I said in previous videos, there's always another way. There's always more than one way to write whatever chunk of code you're trying to write. And you need to understand just what's more comfortable to you and maybe what makes more sense for your specific program. But generally, just for a in values or for a in range length of values, they do the exact same thing. So now we're looking at two other keywords. I guess we're looking at two other keywords, in and not in. So we've already used in the for loop, right? So all this means is everything within this value here. So usually the value that you're using within is going to be a list, or is going to be maybe a dictionary, maybe a tuple, whatever it is. It's going to be a series of values. So all the in keyword does is say inside that entire series of values. Not in is just the opposite of that. It's not in that entirely series of values. You could use, I've never tested this if I'm honest, could use not in, but I don't think it would work. It would probably give you an error because there is a default not in keyword. But the not in keyword, and if you're not using it in a for loop, is returning a true or a false. Right? If you're just using it as a parameter, as a Boolean expression, right, then it's going through all of the values, in this case 1, 3, 5, and 7, and it's looking for an 11. So you're saying, is 11 in these values? If it is, it's returning true, and if it's not, it's returning false. So this should be an 11. So 11 not in these values would return true, but 11 in the values would return false. So this is the in and the not in keywords. And again, we use the in already in the for loop, but the principle here is using it as a Boolean expression. It's looking inside all of the values that are associated with this variable, all of the elements that are associated with this variable. It's searching through them to see if it exists. So this is a lot like the Control F maybe in Microsoft Word. is looking through every single word in that document to try to find the word that you are searching for. That's what this in values is doing. Not in values is just doing the same thing, but it's just returning a different result based on what it finds. Alright, so this is something that when I was preparing for this exam myself, I didn't actually necessarily know this. So you can create a list based on existing lists. Now, I knew you could set a list equal to the values in another list, but I didn't think, and I just never processed the idea that I could do math with the values inside of another list and add that to its own list. So what this is doing is it's taking numbers 1, 2, 3, 4, 5, and within that list of numbers, right? So inside this entire variable, all it's doing is squaring the numbers. So you're going to get 1, 4, 9, 16, 25, which it is represented right here. So that is now the value of the squares. You can do this with any list. You could do any mathematical formula here. You could add, it doesn't matter. You could do any formula here, and it's just looking at every individual value. It's evaluating this formula, and then it's moving to the next value, and then evaluating that formula. So that's the list comprehensions. It just brings in the values from one list and then uses it into another list. What I was much more familiar with was the idea of copying a list or cloning a list. Again, there's always more than one way to do anything, right? So you can either use the copy function or the slicing function. Now the copy function is really easy. You just name the list, .copy, and it copies everything over. If you're using the slicing function, remember when we use the slicing function, we have a start parameter, a starting index, and an ending index. If you just leave those two indexes empty, then it picks from the entire beginning and all the way to the end of the list. So it basically selects the entire list. Sometimes, if you want to just copy part of a list, then you're definitely going to want to use the slicing function, right? Because you can go from index 6 to index 20 instead of index 0 to index 100. You can pull out individual sections that way. But if you're trying to copy the entire list, I'm probably going to use the original .copy here. But when you're trying to copy portions of a list, you can use the slicing. Now, I imagine that some people use the slicing all the time just because it's easier to use the same tool. Even if it's not the perfect tool for the job, it's good enough. It does exactly what you need, and then you don't have to have this secondary tool that you're remembering and bringing around. But it's up to you which one you use when you want to copy a list. So the last element we want to talk about is this idea of a matrix. This is a 2D, it could be a 3D list. 2D means two-dimensional. When we look at the image here, you have a 1, 2, 3, 4, 5, 6, 7, 8, 9. But these are in 3 different lists right here. So we talked about the idea that a list just stores data. A list could store integers, it could store strings, it could store floats, but it could also store other lists. So you can store a list of lists, and that's what a two-dimensional matrix is really just storing a list of all of these other lists. And what that does is that gives the two-dimensional list, every item in the list now has an index that is more like a coordinate. So instead of being matrix A or matrix 1, you now have matrix 1, 1 or 0, 1 or 1, 2. Just like you would if you're looking at a graph and you're trying to find, or an Excel spreadsheet, every cell has its A1 or A3. It's very similar concept. It has, every cell has coordinates, and that makes it easier. You can access positions a lot quicker when you have the coordinates than if you were trying to have 2 separate lists and do a lot of different searching between them. So a 2D list is great. You can also have a 3D list. This is called a box instead of a matrix, technically. So a 3-dimensional list is a list that has the data type is other list inside of it, and those secondary lists, the data type in those are other lists inside of them. this would give you it represents kind of a three-dimensional space, right? So you have an X, Y, and Z instead of just an X and Y. I don't really use that very often. I use the matrix more regularly. I don't really use the box list, but I understand the principle of why. It's just never something that comes up that I need. So we'll look at an application of all of this stuff in the programming. And I want to make a note. This stuff definitely makes more sense when we see it in action. But because we've already looked at 80-85% of the tools that we're always going to need, then the application now is in the actual code of it. So the next week, again, this is the last video for this first week. Next week, we're going to do a lot more videos of actually applying the code. We are going to have to look at creating our own functions and parameters and things like that. So the first day might have a little bit more presentation, but after that, it's going to be more of an application of the code. So that's it for this week as far as the presentation, and we will have a video of coding and representing all of this in Online Python coming up. So we'll see you there. Thanks.